Sea levels around the United Kingdom have been rising since the end of the last glacial period, a time frame that began approximately 20,000 years ago, when the Earth's climate cooled and ice sheets formed across much of the northern hemisphere. This initial rise was gradual, but accelerated significantly during the Holocene thermal maximum around 5,000 to 7,000 years ago, as global temperatures increased slightly, leading to melting glaciers and warming oceans. The rate of sea level increase has varied over time, with notable periods such as around 1800 AD, when sea levels rose by an average of about 1 millimeter per year. The key developments in the study of sea level rise in the UK have occurred over recent decades. In 1973, British scientists launched the first comprehensive global tide gauge network to monitor changes in sea levels worldwide, including in UK waters. By the mid-20th century, it was evident that rising sea levels posed significant risks for coastal areas of the UK. Several major turning points have influenced understanding and management strategies for sea level rise in the UK. A critical moment came with the publication of Sir Robert Hitchens' report on UK flood risk in 2011, which highlighted the urgent need for coastal defenses to protect against rising seas. Since then, investments in infrastructure such as seawalls, levees, and other protective measures have increased substantially. The measurable impacts of sea level rise in the UK have been substantial. Coastal flooding events now occur more frequently than they did historically, with some areas experiencing an increase of up to 50% in annual flood frequencies since pre-industrial times. This has led to significant economic burdens. For instance, the UK insurance industry alone spent over £4 billion annually on coastal flooding between 2016 and 2018. However, sea level rise also brings certain benefits. For example, it can create new lands as water levels recede, providing opportunities for coastal development or reclamation projects. Additionally, some marine species that depend on tidal ranges may benefit from warmer ocean temperatures associated with rising seas. The long-term effects of continued global warming and subsequent accelerated ice melt mean that sea level in UK waters is expected to rise by approximately 35 centimeters by mid-century, based on current climate models. By the year 2050, many coastal communities will need to adapt more intensively through enhanced protective measures or relocation if they are to avoid severe damage from rising seas. To optimize future projections and responses to sea level rise in the UK, continued research into precise long-term trends is necessary alongside proactive planning at both local and national levels. This should include comprehensive monitoring systems for early warning signals of climate change impacts, as well as investments in resilient infrastructure designed specifically to withstand projected sea level increases. Furthermore, promoting public awareness about these issues could help garner more support for policy measures aimed at mitigating the severity of potential future consequences.